My name is Nicholas Edwards, and this is my presentation on the friedal acylation. In 1877, Charles Fried, a French organic chemist who was chair of organic chemistry at Sorbonne, collaborated with James Kraft, an American chemist who was professor of chemistry at the Massachusetts Institute of Technology, to discover a chemical reaction now known as the friedal, which is where you take an aromatic compound and react it with an alkyl chloride under an aluminium trichloride catalyst, which substitutes the aromatic compound in instead of the chlorine atom, creating the product an HCl. This is usually done at 60 degrees centigrade for 30 minutes. I want to talk about where this is used in industry. The first thing I want to talk about is ferrocene. Ferrocene is an organometallic orange solid. It's mainly known for its stability. It can be heated to 400 degrees centigrade without decomposition. It's used as an additive in fuel to allow vintage cars that run on leaded petrol to run on unleaded petrol. The second thing I want to talk about is benzaldehyde. Benzaldehyde is a colorless liquid with a marzipan odor and is used as cake flavorings and things of that nature. In 1999, 7,000 tons of benzaldehyde was synthesized, as well as 100 tons being synthesized naturally. The last thing I want to talk about is naphthalene. Naphthalene is a crystalline white solid used in mothballs. Due to its strong odor, it can be detected at concentrations as low as 0.08 ppm by mass. Due to its strong coal-like odor, it's a good deterrent against moth infestation. I'm going to talk about the mechanism. The first thing that happens is the departure of the chlorine from the acyl chloride, which forms AlCl4- and an acylum ion, which is a stable carbocation. The second thing that happens is the alkene bond in the benzene attacks the acylum ion, which breaks the delocalized benzene ring. And the third thing that happens is a proton is removed, reforming the aromatic ring. Notice how the catalyst reforms at the end as well. We actually did this reaction in the lab, as you can see in the photo on the bottom right. I'm going to talk about some extras. This process is used in the human body to synthesize DNA and vitamin D to attach their aromatic compounds. I'm going to talk about some limitations now. The first limitation is, as you're replacing the chlorine with an aromatic group, it can only be used to synthesize ketones. The last thing is this reaction does not work with a deactivated benzene, as they are less reactive. Thank you very much for listening.